Okay, so for each problem, fill in the missing equation or description of the transformation g of x in terms of the original f of x. That's kind of code for there must be an f in your equation, right? So if it is stretched vertically by 12, what are they giving me? Are they giving me an a value, a b value, an h value, or a k value? A value. So that means g of x equals a times f of x. And that's what I got. Get it? Translated 2 units down, is that an a, a b, an h, or a k? That's a k value. So that would be f of x and then minus 2 outside. Yeah? This one, I gave you this, and it looks like you have to fill in the word. So what is this? This is a what value? A, B, H, or K? H value of what? -7. So that is I'm going to use the same language that's listed here just so that we remain consistent. It's a translation, so it's translated. How? 7 units left. Okay. Translated right to A, B, H, or K? H. So that would be f of x. And let's see, if h is positive 2, it needs to look like -2. Here's another one where I have to fill in the words. What do we have going on here? A, B, H, or K? B is negative. So what does that mean? Horizontal reflection. And then finally, compressed vertically by 2/3. A, B, H, or K? A. So that would be 2/3 f of x. Each one of those blanks was 1 point. So this whole part was worth 6 points. Okay. Any questions there? All right. Moving on here. Choose true or false for each statement about the function. Well, if I look at this, I have a negative leading coefficient that tells me the right side goes down. I have an even exponent which tells me the left side goes down and there's a bunch of bumps in the middle. Yeah? So, is the domain of the function from -infinity to infinity? Yes, that's the way we write all real numbers, correct? All right. As x approaches -infinity, what side of the graph is that asking about? That means it's asking about the left side, because -infinity would be the left side. Is it going up on the left? No. Nope. The range of the function is -infinity to infinity. Now, there's 2 issues with this one. First off, the range is definitely not all real numbers. But the other issue is the fact that range doesn't deal with x. So there's 2 reasons why that one's false. And then this one, as x approaches positive infinity, what side of the graph is that asking about? Right side. Is it going down? Yes. So? Okay. So those should be really easy on the computer, true, false, right? I'll have a drop-down menu, you just pick true or false. For this guy, I found a way to write a question. I'm really excited about it. It's a drawing tool on there. So you can actually just click it and just do your sketch, and then I'll look at it. It'll be fun. Okay, so sketch a graph. I have a negative leading coefficient. What does that mean? Right side goes down. I have an odd degree, which means what? Left side goes up. It is a degree of 5, which means how many bends? 1, 2, 3, 4. Some people think that means that there are 5 bumps. That's way too many bends. It's not 5 bumps. 1, 2, 3, 4. Okay. There was some group that did like 1, 2, 3, 4 like that. Because they got the 4, but then they end up with 1, 2, 3, 4, 5, 6, 7, 8. Way too many bumps. Okay. The way I'd split up the 3 points was you got 1 point for the left side going the correct direction, 1 point for the right side going the correct direction, and 1 point for the correct number of bumps or bends. Okay? Good enough? All right. Identify the information. Leading coefficient, is it positive or negative?
Negative.
How do I know? Right side's going down. Is it odd or even?
Odd.
How do I know?
There's 2 bends.
Left side is opposite the right side, correct? Least degree. I see 2 bends, which tells me the least degree is at least a third. You don't need to worry about writing the at least, just write the number. Okay? End behavior. Positive infinity means the right side. Right side is going down, so that should be negative infinity. Left side is going up. Domain, range, and on the test tomorrow I'm going to set it up so that it doesn't matter whether you write it in interval notation or you use the R or if you write it. I will say that interval notation must look like this. This messed up a lot of people on the quiz because they put positive infinity first. We always do least to greatest, smaller number first. Or if you write it like this, negative infinity is less than x is less than infinity. Any one of those 3 notations will be okay for the test. Okay? Same thing with the range. You could use this notation or this notation. The only difference is if you use this one, you have to put y. Okay? All right, leading coefficient here. Degree. How do I know the leading coefficient's negative? Right side goes down. How do I know it's even? Left side is also going down. Least degree. 4th degree, because I see 3 bends. There was one group in this class that did the did the thing that drives me nuts. I don't know if it was this question or the next one, but they said like odd and then said 4th. Well, if it's odd, then the least degree should be an odd degree, right? Or one of those is having an issue. End behavior. Positive infinity is talking about the right side. Well, it doesn't really matter because in an even, both of them are going down. Yeah. Domain. Always all real numbers. Doesn't matter if it's odd or even, it's all real numbers. Estimated range. Now, this one does have an uppermost point, correct? So I would say it looks like it goes from negative infinity up to 3. So you can write it that way. Or you can write y is less than or equal to 3. Or you can write negative infinity is less than y is less than or equal to 3. Any one of those notations would be appropriate for the test. Capiche? First page should go pretty quick. Yeah? This is where people spent most of their time, I think. It was on page 2. Maybe not. Maybe page 3. All right. Leading coefficient, positive or negative?
Positive.
How do I know? Right side's going up. Degree, odd or even? How do I know? Left side's going down. Opposite ends, right? Least degree. 1, 2, and then whenever you have an inflection point, you've got 2 bends. So if there's 4 bends, I would say 5th degree. I think this was where a group put odd and then they put 4th. End behavior on the right side, what's going on? Up, left side, down, domain, range. So if you know what we're talking about, those questions go very fast. Okay? All right. A function f of x is graphed as a solid line. Write an equation for the dotted line, g of x. Now, keep in mind, is this a linear, quadratic, cubic, quartic, any of those? No. It's just some random function. Since I don't know what to call it, I have to write my equation in terms of f of x. That means there must be an f in my answer. Okay? So let's see what's going on. I'm going to focus on this point right here. Okay? And it looks to me that it's like there's like a V shape and almost like a curve, like a parabola, kind of like a half a parabola. And that V shape is still on the left, and that parabola part is still on the right. Do you see that? So that tells me horizontally it has not flipped. Do you understand? Because if it was horizontally flipped, the V part would be on the right and the parabola part would be on the left. I do see, though, that the V is right side up here and upside down there. So what does that tell me? My A value is negative. Now, if I do a reflection, let's think about this. That point that I said I was going to focus on, how far up is that? That's 6 units up. So a reflection, flipping it, would put it 6 units down. So once I've reflected it, let's see, this was 3 units up, now it's 3 units down. Once I've reflected it, we're going something like this. So once I've reflected it, it doesn't look like I have any stretches or anything, do I? So I'm just going to call A -1. And what direction did it move then? Only to the right. It moved to the right 1, 2, 3. So right 3 would be an H value of 3. There's no K value because it hasn't shifted up and down. It looked like it had shifted up and down at the beginning, didn't it? But if you catch it once it's reflected, you notice that it hasn't moved up and down. So I just need to put that in there. So -1 would look like that. And then f of x -3. So? That one takes a little thinking. Okay. Okay, I'm going to jump to number 14 real quick, and then I'll go back to 13, because 14 is very similar. I have an f of x, I have a g of x, and I have to come up with an equation. Now, the difference is, I know what kind of graph this is. It's not just a random V and parabola-ish shape. What is it? It's a cubic, which means there is no f in my equation. There is a cubed in my equation. Understand? It's important to know the difference. When is there an f? When you don't know what kind of function it is. When it's a cubic, we take the f out and you put the cubed. There were some groups that put both the f and the cubed. Those are two different circumstances. It either has the f or it has the cubed, not both. So, a cubic function is graphed. Write an equation for this guy. Okay. Do we have any reflections going on? No. How do I know? End behavior is the same as the parent function. That's how I know there's no reflections going on. So if I talk about A, B, H, and K, if there's no reflections, I shouldn't have to worry about a B value at all. Okay? In fact, for most of these, I'm not going to need to worry about a B value at all. If I want to see H and K, those are easy. Just take your original point of inflection, and where did it move to? It moved 1, 2, 3, 4 units right, and 3 units up. So both of those are positive values. So far, so good? How do I find A? The box thing. The box for the parent function, remember, is always 1 by 1. What's the box for this one? It's 3 tall. So what's my A value? So now I just got to plug it in. 3, parentheses, remember, no F because we know it's a cubic. X, what? -4 cubed plus 3. So? We doing okay there? All right. Number 13 messed with some people because they saw this and they thought, okay, I have to take the graph that's on there. I need to compress it by 1/2. I need to reflect it, and I need to shift it left, and I need to shift it down. Right? Many groups, their brains went to that place. When we graphed cubics, we didn't do that. What did we do? We put the inflection point in the middle of our XY table, right? And then we went from there. So what is my point of inflection? -5, -2. That's the new point of inflection. In fact, I could graph this without the parent function even being there, right? It's just there for reference to kind of remind me of what shape I'm dealing with. What do I do once I put that in for my point of inflection? I put values around -5. So -6 and -7 in one direction, -4 and -3 in the other direction. By the way, of the 7 points, this was 5 of those points. Because I wanted to know that you had the XY table set up. Once you have the XY table set up, the graph itself doesn't need to be worth very much because it's just a matter of plotting points and connecting dots, right? This is where it's important. So how do I find those values? Plug them in. -0.5, and I'm just using 0.5 because it's easier than plugging in the fraction. Parentheses, -7 plus 5 to the third minus 2. And I get 2. Now I'm going to arrow back, and I'm going to change the -7 to a -6. And I get -1.5. Change the -6 to a -4. -2.5. And then change the -4 to a -3. -6. And now is the easy part, just plotting in points. So -7, 2, -6, -1.5, -5, -2, -4, -2.5. There's my 3 in the middle. Remember I said there'd always be 3 in the middle fairly close together. And then -3, -6. So there's the 3 in the middle, and then these two should be equidistant pretty much from your, you shouldn't have like one here and then one all the way down here. That would throw you off. So connect your dots. And there you have a graph that is the same as this one, except it has been vertically reflected, compressed by 1/2 vertically, shifted 5 units to the left and 2 units down. So? So again, this was 5 points, this was 2 points for being able to transfer that to here. Okay, any questions there? Last page. And this was the one where I told you we forgot to draw in the lines before we copied it. So just to preface this, if you see that on the test tomorrow, that was what it was supposed to look like. The random XY is not supposed to be just by itself. Okay, so we have something in intercept form, yes? Okay, so what are my x-intercepts? From here I get x equals -2. Don't worry about the multiplicity. I'm just worrying about where are the x-intercepts. Okay, and here we have what? 1. You could write it like that. You could write it like this. Either way there is appropriate. Could you write it like this? No, because you have now turned that from an x-intercept into a y value. Not to mention that point is not on the x-axis at all. So you can't write it like that, but you can write it either of those two ways. All right, so -2, 0, and 1, 0. There are 2 grid lines between those 2 points, aren't there? Do you see that? 1, 2. So when there's 2 grid lines, I said go ahead and put both of those in your XY chart. So -1 and 0 both go in your XY chart. I believe I gave 1 point apiece for each of these. I don't need any other values. Some people had like 8 values in their XY chart. I don't need other values. Those are the only 2 that I need. Okay? If I plug in -1 here, -0.5 times -1 plus 2 squared, parentheses, -1 minus 1 to the third, I get 4. So -1, 4 is on my graph. And then if I go back and I change both of those x's to zeros, delete the negative sign and call that a 0, I get 2. So 0, 2 is on my graph. So let's figure out what this is going to look like altogether. What is my leading coefficient, positive or negative? Negative. That means the right side's going to go down, correct? Okay, so I know right side down. And then what's the degree? 1, 2, 3, 4, 5. So it's odd. What does that tell me about the left side? Okay, and at x equals -2, I have a kiss. And at x equals +1, I have an inflection point. So if the right side's going down, then my inflection point is going to be going something like, got to flatten out a little bit like that. And over here, I know the left side's going up, and I have a kiss going on, so it's going to bounce up like that. So it's kind of funky, but in general, that should be sort of what it looks like. Last thing is end behavior. Right side is going down. Left side is going up. Any questions there? Okay. Ready for the last one? This is a test where if you know what you're doing, it really shouldn't take you very long. It goes pretty quick. All right, what are my x-intercepts? Well, from here I have 2. Here I have -1. A lot of people missed this one. 0 is also an x-intercept because there's an x out in front. So again, you could write it like that, or you could write it like this. 2, 0, -1, 0, and 0, 0. You could write your intercepts like that also. Okay? So let's see. 2, -1, and 0. Let's see. What's going on the right side? Is it going up or down? How do I know? Leading coefficient is positive. So the right side's going up. Is there anything funny about this 2? It's going to be a kiss. So I know that it's going up there, and it's going to bounce, right? What degree are we talking about? 1, 2, 3, 4. So what does that tell me about the left side? Also going up. Anything funny about that intercept? Nope. So what do I need to know? I need to know what's going on between these. So between -1 and 0, -0.5. Between 0 and 2, 1. Those are the two values I'm looking for in your XY chart. So let's see. 4 times 1, or let me do the -0.5. -0.5, and then -0.5 minus 2 squared, and then -0.5 plus 1. -6.25. Now I'm going to go change all those -0.5s. Actually, I think it'll be faster to just type it in again. 4 times 1. 1 minus 2 squared. And 1 plus 1. I get 8. So there's my two values. So let's see. -0.5, -6.25. All the way down there. And then 1, 8. All the way up here. You okay with that? So this is going to come all the way down before it comes back up. And then this one's just a plain old pass-through, right? It's going to come all the way up to here before it meets down with that bump. Okay? There was at least one group, possibly two. I think it was on this one. They ended up crossing the x-axis again somewhere around here. You cannot touch that x-axis except for the places that you have mentioned on your x-intercepts. If you're crossing the x-axis any more than those two places or these three places, then we got issues going on, right? because if you're touching the x-axis again, that would be represented in the equation. Okay. Let's talk end behavior. Both ends are going up. Any questions there? All right. My job's done. Happy studying.